Okay, good morning everyone, and good afternoon for those on the East Coast.
Nice costume, Neil.
Yeah, sorry about some of the extra animation and photos that suddenly appeared in the presentation without my knowledge.
Okay, I think
It's
we're
pretty
ready
spooky.
to...
I think we better start. Welcome.
Yeah.
We are going to be talking about passive RFID sensor tags today. Towards the end, at the end of the presentation here, we will be taking some questions. So if you type questions into the question section in the interface there, we'll go through some of those at the end.
Let's get started.
Let's get started because that blinking's killing me.
It is a little overkill, isn't it? It's not subtle.
All right.
So, we live and work in Silicon Valley, although our customers are all around. And here, artificial intelligence and big data and cloud computing and all that's a really sexy thing. And it's interesting, we come from companies that make stuff, and there's not as much attention to how do we elegantly capture this data and what data do we want to capture. So we're really committed to a solution. Wait, you gotta wait for it.
Oh, jeez. Like we said, there's some extra animation that seems to have suddenly appeared in the presentation since the last time I saw it. The goal here is to really make data capture, sexy and as useful as data analytics is seen today. Data capture really has been ignored by the industry to a certain extent. There's so much focus on the data analysis, but if the data that's coming into the data analysis is bogus data anyway, or slightly inaccurate, or
incomplete,
that's
a larger problem,
or not the right type, then clearly no matter what data analytics you do, you're not going to get the desired outcome. So having the right type of data capture in the right way can only be helpful, and using multiple sensors, not just necessarily relying on one.
Right.
Which I guess leads us on to next slide. So the old-fashioned way, traditional way of data collection is not really looking at what it costs to install these sensors, what sensors to use, how to put them together, how to power them, what type of data is needed.
Right.
All these sensors are regarded as separate little islands and not necessarily working together. There's a lot of other companies in our industry that are just treating RFID again as a silo in effect, so that everything's going to be sold with RFID and nothing else.
Right. And our approach is a lot different, and that is that most people aren't, most of our customers aren't married to RFID as an industry or as a technology. They just have a problem. They want to know how many boxes and what kind of boxes. And they'd like that to be a lot simpler. And so much of what we try and do as a company is be a broker that sort of translates that into an approach that brings the sensors and the infrastructure to the end customer or to our integrators that we work with, so that it goes in a very different way. An easy example is portal, and virtually everybody on this webinar knows what a portal is. A typical portal can have a NEMA box, it can have a fan, it can have a reader, it can have a GPIO box. It might have a separate camera system, and the point is all of that is included inside of our products. So you get the reader, and you get a powered GPIO that's included in the reader, and that's where we're headed. We like problems that need multi-sensors, and we like problems that are a little bit interesting to thread together.
And as you'll see as we kind of go through this material here, that when we talk about sensors, the sensors can actually be either in the reader or they can be on the tag.
Right, so let's talk about sensor tags.
Let's do that. Didn't know you were Canadian. So what's the difference between active and passive tags? Active tags by definition have some kind of power source, usually a battery. So that defines really the lifetime of that tag. Can be from maybe a few months to a couple or 3 years. Versus a passive tag, which is really just harvesting energy from the RF that's being transmitted from the reader 30, 40 feet away. So there's no batteries involved. So the lifetime is really the lifetime of the tag itself. And if it's a conventional tag, which is based on maybe PET substrate, then you're talking of something of the order of 50 odd years. There's a form factor difference clearly, because tags, active tags have batteries. They're by nature much more bulky. Minimum probably key fob size to all the way up to kind of large brick size really, versus more of something that looks like a label. Tag cost is also kind of follows a similar trend, a couple of bucks to maybe even hundreds of dollars for an active solution, whereas a passive tag could be anywhere from 3 to 5 cents on the low end up to maybe $1.
Yeah, and it's just a tangible example there. We had a customer wanting to do temperature tracking with a Bluetooth beacon, and of course we can chat. Our readers can chat back and forth to Bluetooth beacons, and that in volume was about a $25 to $30 item to hit their specs. And of course, a passive tag, it couldn't give temperature logging, so it didn't hit those specs. But a temperature tag is well under $1 in this RFID. Yep.
Yeah. The reader cost is an interesting one because that kind of turns things around a little bit. You could argue that Bluetooth is actually, for example, for an active tag, is pretty low cost, although quite frankly, by the time you stick it into a cell phone, it's a $1,500 cell phone these days. So maybe not as cheap as we would like it to be. On the passive side, traditionally RFID readers have been pretty expensive, $1,500, $1,000. With the reader technology we have, we're getting closer to the $500 area. So I think we're hopefully driving the industry down the right path in terms of cost of ownership of RFID here.
Yeah.
There is a big difference, though, in the way active and passive actually monitor and record the tag data. In fact, that the passive tags tend not to necessarily record the data. You kind of can do. You can save some data in the user memory. But
that's a little bit of a hack.
But yeah. But really the big difference is with an active tag, you usually have lots of memory. And you can be monitoring whatever sensor is on board that tag at any time. Whereas, of course, with a passive tag, it's only powered up at the time the tag is in the field of the RFID reader, so it's only active reading at that point in time. And then finally, the read distance, as you might expect, passive tags is a little bit smaller versus the read distance of an active tag. Could be hundreds of meters, maybe even miles in some cases, because you have some kind of power source to drive that RF communication.
So active tags cost a lot more, but they're much more sophisticated and much longer range.
Correct. But the interesting thing is now there are passive tags that actually have sensors on. And that's where things get interesting. And as we kind of alluded to in the prior conversation, on the prior slide, we do both. We can read and access Bluetooth low energy beacons, for example, read their sensors, and now do the same with passive tags as well.
Right.
So just real quick, we try to kind of take a fairly high-level view of what's going on out there with the semiconductors, the ICs that are going into the tags that power these passive sensor tags. And there's really two main players out there today. There are some others that we don't talk about here because they're mainly their solutions are mainly focused on chips that go onto printed circuit boards.
And we may have missed somebody.
Yeah, and if there is, let us know.
We don't mean to leave anybody behind, but these are the two we've been looking at.
Yeah. So Axon used to be RF Micron. We've been spending a lot of time with Magnus chips, particularly the Magnus 3 chips. And those guys are looking, the chip is actually capable of both monitoring temperature and moisture. And it is a completely passive RFID tag, RFID chip. EM Microelectronics, EM4325, for example, is another chip we're looking at. Today, that just does temperature. I believe that EM's working on things that will do moisture in the future as well. And the EM solution can be treated as a purely passive solution, or it can also be paired up with batteries for a battery-assisted passive, kind of a hybrid between an active tag and a passive tag if needed as well. So these are the chips that kind of go on to the inlays, the tags themselves. So let's take a look at those. But before we do, just note that at least here in one case, there is a chip there that's capable of doing both temperature and moisture. However,
incidentally, most of the discussion will be on that chip, and most of it's focused on moisture, because moisture is a little tougher. We'll talk a little bit about that, but getting good moisture detection quickly is a focus of the work that we've been doing.
Yeah. So today, and this may change in future, but today, if you take one of these ICs, even an IC that does both temperature and moisture, by the time you actually put it into an inlay, as you see here, you're basically designing the inlay to focus on an accurate measurement of one type or another. So you design the inlay for an accurate temperature measurement, or you design the inlay for an accurate moisture measurement. And in theory, the other is less accurate and shouldn't be relied upon. Again, that may change over time.
Yeah, it's funny because Neil and I have a technical dispute here that as of this webinar we haven't fully resolved. When we talk about how these tags work, you can understand, particularly for moisture, why the moisture tags are a bit different. On the temperature side, there is some belief here that a moisture tag can do a good job with temperature in terms of accuracy. But maybe we can go ahead and we can talk about how this works and get people some understanding there.
Yeah, this is kind of where things get a little bit more interesting.
Yeah, so in general, the way to think about this is you have a tag and it has different data registers, and these sensor tags are writing data into some of the additional areas of the tag. On temperature, it's fairly easy. You basically interrogate the tag and you go to some different registers, and there is the value for the temperature. And moisture is a different creature, in large part because of the physics behind it. So what's happening here is there's the inlay, which is basically an RF antenna. The properties of that antenna change with moisture. So the resonance properties and probably the real and the imaginary part of the impedance of the antenna move around as you get it moist. And what the tag chip is doing is the tag chip is actually looking at how the resonance of that antenna is changing. Really pretty sophisticated thing. To get it to read properly, as we're going to talk about, you have to your reader has to move this tag into a sweet spot. And so there's a lot of chatter back and forth between the reader that happens really quickly to get the tag in a happy place to give decent data, and we're going to show some of that.
Right.
In addition, and we're going to talk about our partnerships here. SmartTrack has been a really wonderful partner for a lot of this work, and how we calibrate these tags between the end customer, SensThys, and SmartTrack. There's clever ways that we can calibrate so that the end customer can, in the field, get really nice, accurate moisture measurements.
Yep, calibration.
All right.
Okay, so if we take a look at like a scatter plot of the raw data that we get out of these kinds of tags, then you can see very quickly it's not a very simple graph, right? It's complicated. There's effectively for a single percentage moisture content of the material, which you see there in the bottom right of the graph, that effectively there's kind of a line across the graph there based on different properties from the reader and tag. So somehow we've got to make sense of the data coming out of the tags as we read the moisture, and that's kind of some of the secret sauce.
Yeah, and we don't mean to be excessively secret here. What needs to happen is the tag has to be sort of powered at the right level. And so these tags, if we're looking at the M3 chip, it actually has an onboard power meter. So the reader's chatting back and forth and picking up the identification, the EPC of the tag, and then looking at various registers where the sensor values are, also looking at the power level of the tag until you get the tag into a happy power level, and then it's quickly taking a series of measurements and taking an average of that. And the trick for that is, how do you collect enough data so that you understand how to do that quickly? We've taken about 50,000 measurements here. And so we're pretty comfortable with getting the data in and out of these tags fast, so that you can, if you're got a handheld and you're in a bathroom trying to find a leak, or if you're up on a roof pushing a cart around trying to find a leak, those can all proceed at normal speeds.
Yeah. So basically, if you take all the but basically work on this algorithm, use the statistics, and do what we've been discussing here, what kind of comes out at the other end of things is the graph you see more on the right-hand side here, which is obviously a lot more simple. And so we can start to plot here, the moisture values, kind of come out of the data and using these algorithms.
Yeah, and to help your end users understand how simple this is in the end, given the calibration work that we're doing at SmartTrack and the readers and software that we put together, basically you point at a tag and 1% pops up. You know how moist it is, or 2% or 10% or whatever. As an aside, it's kind of interesting working with these building materials. We literally got like these little concrete blocks with tags buried in them. You bake them in an oven and you get the dry stuff, and then you just leave them in a bucket of water overnight to get really, really wet. And what's happening here is these things are drying out as we're getting the less and less wet data points.
Yeah. Okay, so that's kind of some of the kind of the theory and background behind it. So we'll go a little bit more practical now, and we'll show you what we've done with the algorithms and how it's actually presented to you in terms of an application.
Right.
So this is the temperature and moisture sensing application that we've been prototyping, and so this basically is work that we've done with SmartTrack, a couple of SmartTrack customers, and of course our partner MTI. And what we're doing here is effectively interacting with the tags. Of course, we're getting all of the EPC information or TID, whatever we happen to need in that particular case, in terms of identifying the tag and identifying the object that the tag's attached to. But we're also getting the temperature and moisture values from the tags. And then what we're also doing is we're getting the location information, and we'll talk more about that in a second. But the console basically gets all of this information and can present all of this. I'm not showing the whole UI here, and this is going to continue to further develop. But so we can present the moisture data. We can present the GPS data and actually interpret that on top of a Google map. So you know what something is, you know the condition of it, and you know where it is.
Right.
So the other thing that we've taken is we've gone a step on the hardware side and basically developed what we call the sensor kit MT for moisture and temperature.
Really
not exactly rocket science, is it? So the kit is, as you see here, so this is basically based on the SensorRay Pro reader, which incorporates 33 dBm reader, antenna, PoE ports in and out, GPIO, power GPIO. And the kit includes that, the PoE injector, class 4 PoE injector, all the cables you need, and of course a selection of moisture and temperature tags from SmartTrack. And it's available now.
Trick or treat.
Trick or treat. And the list price is $999. However,
Yeah.
boy, do we have a deal for you.
Press the button, man.
Oh, man, okay. So for Halloween only.
That means literally, it's got to be in to Neil by like 11:55 p.m. and he'll promptly respond to y'all.
I think Joe actually wants me to stay up till midnight just to. But anyway, we are going to make this available to attendees today for $699 for the whole kit. Seriously, it is just for today only. So, send me an email. My email address there is there, neil.mitchell@senthis.com. And we'll be happy to get a kit out to you. And it's a good deal.
Yeah, it is. We are working a relationship with a development partner for this, and we'll let everybody know that in the future, so it'll be convenient for you to get them if that comes to pass. But for right now, because you're on here and we wanted to get something special to you guys,
yep,
here you go.
Right. So this is all good. One thing we kind of skipped over is locations. Let's talk about that. So the way we get location is using the reader. So we have an IP67 reader, the SensThys Extreme, and apart from being built like a tank and being IP67, which means it's effectively water resistant to spray and dust particles, etc. This thing can actually, we've dunked it in swimming pools. It's gone through 1 meter of water testing. It's gone through Mill 810 shake, rattle and roll. It's all of this kind of stuff. We park cars on it. Very robust.
Right.
But in addition to that, it's got a bunch of sensors inside of it, and one of those sensors is GPS. So we can get location. We actually have gyros in there and accelerometers, so we can also tell if there's some movement going on with the reader in terms of direction and if something's been shaken that shouldn't have been.
Yeah, it's worthwhile to take a moment back. It also has an amazing amount of computational and memory capability, a lot more than you're typically seeing in this market. So it's got a quad-core ARM processor. Happy to give you all the specs on that processor, but a dynamite little computer in there. It's also got a removable card or exchangeable card. It comes shipping with 32 gigabits of memory, but I think that can be all the way up to 0.25 terabytes of memory if you'd ever need something like that. So it's a real capable, if you've got an edge device on a network and you need to control a whole bunch of sensors, this is a really good choice for that too.
Yeah. So this is how we get location and moisture and temperature data together. So let's take a look at some applications. Let's take a look at construction first. This is a great application. And even within construction, there's multiple kinds of applications. But if you take a look at concrete, whether it's a foundation, wall, a road, or even bridge components, something structural, anything that has concrete has a cure time associated with it. And that cure time varies tremendously based on the type of concrete being used, the outside temperature, all kinds of other factors.
And because it varies so much, if you're building a building, the building inspector will say, no, you can't do anything until the foundation is super duper cured and everybody's confident. So after it's poured and after it's cured, there's typically many, many days of waiting to go build stuff. And what the construction industry is pulling on in the thread here is a way to check when is stuff cured and ready to be to bear a load, and that's what we do here.
Yeah, I mean, sometimes they're just waiting for the builder, inspector to come back and do some testing. But if you have tags embedded into the concrete structure, based on the variation in temperature and obviously the moisture content, we can determine quite quickly, where are we on that cure cycle, and is it actually cured now? So we can optimize the ability for the construction site to just get on, and maybe their particular foundation's actually cured after 3 days and not 5, so they can just get on with it.
Right. Well, this is also quite useful in construction material. We always think of construction material at the site, but a lot of the construction material is prefabbed, and you have these prefabbed big concrete components, pipes or walls, that sit in these huge 40-acre, 100-acre they're outdoor inventory parks, and they need to know when things are cured, number one, but they also lose track of things because these large components often sit in these yards for years at a time. And so having an RFID system that can zoom around this lot, and it not just picks up the EPCs, so it says, the inventory's here, but it also says where is here, so it can tell you where a piece of inventory is in an active way without burdening people with new inventory control systems.
Right. And as you drive around the yard, you can also find out, do testing of things that are going through their cure time and know if they're actually cured.
Right.
And it can cost as much as $25,000 just to do an inventory of some of these yards. So this all helps.
Right. And just to one thing, and then we'll move on with this one, to help people understand how these things knit together. The equipment that you bring out to a yard here, if you were to look at a foundation, it would be a reader and the antennas. Those are IP67, so they're mounted. The IP67 reader is battery powered, and it can run. The processor can control duty cycle, so it can run for an extended period of time without anybody having to come deal with it. But it also has the memory, so it can record the measurements over time, and a nice cellular connection, so it can pop the data out to the cloud, so you can see it without having to visit the site and monitor it in person.
Yep. Another application is smart building materials. So, for example, roofing or insulation type materials. For example, trying to just answer the question, is my roof leaking? Is something damp? Simply adding a passive sensor into that building material, effectively zero cost. Then you have the ability to go and interrogate this roofing and find out if indeed there is a leak or some moisture getting through somewhere where it's not expected.
Yeah, and one of the things to comment about current moisture detection is that it's basically interrogating the surface of something, and it has a difficult time penetrating. So if you went up on top of this roof and you said, where is the roof wet, you'd look at this roof that we show you and you'd say, well, it's wet where the puddles are. But what you're really concerned about is, does the water penetrate into the roof? So you have to read down a little bit, and the surface type instruments simply can't do that. They can't look down through a floor. They can't look very deeply into a wall. And that's a significant advantage here. By the way, when Neil took this out to the end customer and demonstrated the cart, we actually found that the roof was indeed leaky.
Yep.
And they were quite surprised, and that was a good time.
It was a good time. So the equipment we use here is a cart. We used our IP67 reader that we just spoke about. We added a battery to it, and of course tags.
The tags were already in place. The end customer had them in place.
So the cart is a prototype and basically looked something like this. So you can see there's a Windows tablet there to see what's going on in real time.
And here's our intern walking by a bunch of these things, and of course it's popping all of those off and declaring that they're all dry. One comment about this is a prototype, and this isn't what a finished product would look like. It's more to demonstrate what we can do, but it's done very inexpensively and done very quickly to get the end customer visibility. The end customer's now asking the next set of questions, and they'd like this to be a little Roomba. So how do we robotize this, and how do we get it marching around the roof on its own?
Right.
But great start.
Yeah. So let's talk a little bit about partnerships.
Yeah, we really believe very fundamentally in partnerships. I want to give a shout out to some of the people that have helped us here. Darren Prince, our lead guy at MTI, introduced us to Bill Barr in April.
Hi, Bill.
Hey, Bill. I don't know if Darren's on the call. He's just got off the road. And both of those guys have been very, very supportive. We've got to meet a lot of people in SmartTrack. The other piece of this is MTI. And when we do things like this, part of it is our software layer that rides on top of the Empower module, but a lot of it is very deep firmware that's flirting back and forth with the Gen 2 V2 protocols, and not just doing that, but doing that very slick and quickly. So to all those guys, Jay, Eric, Peter, Tony, Alan, Hunter, Kathy, Chichang, TC, Rebecca, and Tom, hats off to you guys.
Good job.
The last thing is, a lot of this is algorithms that work with readers or other sensors. And we are open to partnerships. We think that this industry progresses when we make a lot of things much more economical and much easier to use. And we're not a reader company that just does that. it's bringing more things together in a very simple way so that you guys can reach out to customers and fix their problems, as opposed to being enamored with, minus 85 dB sensitivity at 17 meters and crap like that. That's not what your customers care about. So if you want this kind of work put on a handheld or put on another reader, come to us. We'll figure out if there's some workable business way to get that done for you, so that you can, in a way that works for you, go out and measure some tags.
Yep. A rising tide floats all boats, so they say.
Yeah. So next, I think is Well, so last time we gave away a coffee cup, and we're very proud of our coffee cups. So we're going to give another coffee cup away, but we gave 5 right-hand and 5 left-hand antennas out for one of the attendees.
We did. You did. So I think we should give something else away today.
Yeah, we're up in the ante.
In addition to the fact we're already giving the kit away for a very, very good price.
Yeah. Well, that's not really giving it away. They're going to hear that and they'll say, Neil, come on, man. We're not giving it away.
Okay, well, then we're going to give away something. All right. What are we going to give away?
Yeah.
Okay. Should we give that away?
So this is the next generation reader. It's just coming out. And again, we put a lot of stuff in our readers. So there's a fully functional 4-in, 4-out optically isolated GPIO. That's kind of industry standard, but right at the top of the industry. But it also has a fully powered 24 volt system, so you don't have to have a wall wart. You don't have to spend hundreds of dollars on a separate GPIO box. There's not a separate interface. They're all run together from the same SDK, an API. You can run it right off our console. We have a network switch so we can run data around. There's a really nice antenna inside. There is a world-class reader. Again, cheers to MTI and all the work that our guys have done to make that reader function so well. That's all coming to you. Yep.
So we'll select someone at random from the attendee list, from whoever joined today. So expect to see emails from us. By the way, we are recording the seminar here as well, and so we'll...
So all those Halloween things.
Yeah, thanks for that.
There's one more.
Okay, so we'll try and we'll get this all videoed up and share it with you. But we would like to...
Wait.
Oh, jeez.
Neil doesn't have one of these. Sad Neil. But by the way... it's not just the enterprise reader. Here is actually the enterprise reader. You can't see it on the webinar, but on the film you can. But we're going to outfit it as a sensor kit for you. So not only will you get a power supply and all that, but you'll get the tags and all of the software so that you can use your brand new reader to read sensor tags. One last thing is this is pre-FCC certification. So it'll come with an engineering tag on it. It is the full reader, so once it passes the cert, if you want, we'll mail you a label to put on it that has all the FCC numbers, so you can install it and sell it if you want.
Yep. Okay, so with that, let's go and see if we have any questions. Let's see. Someone said, sorry for joining late. That's a good question.
It's okay. You can catch the whole thing on our website as a video.
Yeah. So if you have any questions, type them in. Otherwise, I think looks like we don't have any. So I think we've blinded them with science.
We blinded them with something. Okay, so we'll wait a couple more minutes. One last thing is, as we're wrapping up this year, a lot of what we work on, almost everything that we work on, is driven by your feedbacks from the testing that we do to the partnerships that we develop. They all come because there's these sticky problems that people need help with. And feel free to email us your questions. Feel free to reach out with what you'd like us to think about working on in the coming year. Do we have some questions?
Yeah, we've got a couple of questions. One question was, what's included in the $699 kit?
Okay.
It's everything you see on the screen there. So it's basically the SensRay Pro reader, Class 4 power injector, 2 Ethernet cables, power cable for the PoE, and selected moisture and temperature tags initially from SmartTrack.
Right. So just as a point there, and maybe the simplest way is, do you get everything that you need? And the answer is, if you hook this up to a Windows computer, we provide you all. There's 2 separate programs we provide you. We provide you those programs. If you have a Windows computer, with a phone call, we'll have you up and running in about 5 minutes.
Yep. Just one clarification. When we take the GPS coordinates, as we were discussing from the reader, when we combine that into our mapping, we can actually map the moisture on the roof of a building and actually produce a moisture map, almost like a heat map. So just wanted to point that out in case that wasn't clear.
That's right. And incidentally, on the sensor GUI that these, whether you happen to be the guy that wins this or you buy one, the sensor GUI stamps out that information for you: the EPC, the temperature of the tag, the moisture sensor, and we can talk to you about how to turn that into a real moisture value. But it also puts out the GPS locations if you've hooked it up to an extreme. This kit isn't an extreme, but if you had this equipment and you were running an extreme as opposed to a pro, you could have all of the GPS information.
Yep. Yeah. Question about the tags. Most of the tags you in the presentation here are SmartTrack tags released. And another question about is tracking laboratory specimens. Is that a good thing to do with these passive sensors, particularly if monitoring temperature? And I think the concern is whether or not you can detect, for example, if something exceeds a certain temperature. Passive tags.
So the short answer is maybe not. Because
depends. It depends if the materials being tagged and tracked for temperature are always within an RF field, an RFID field. If they're not, then
you'd flip over to a temperature logger.
Yeah, you'd have to have some kind of different device to do that.
So it's kind of an interesting thing. Tracking the temperature of something like a blood sample moving through a process is akin to tracking the temperature of food as it moves around. And in those situations, we use RFID to track what it is. So when it pops in the dock door, we say, this is what we've received. BLE temperature loggers are used to say, well, here's the temperature history of the pallet that we just measured. And that may be a better approach for you here.
Yep. We have an existing customer, thank you, Mr. B, who asked about whether or not his existing sensor array probe will support sensor tags. Absolutely. You just need our updated moisture and temperature sensor application.
Yeah, one little shout out to the software team here. There's a major software release that's coming out that if you're an existing customer, you're going to be brought up to speed on, and you can upgrade in the field. It will increase read speed, read sensitivity. It increases a whole lot of functionality with how do you deal with tags and tag populations. So this is a pro user tip. These webinars are always tied to work that's either just being finished or is in the works. And so when we did sessions and selects, a lot of the details that we talk about how do you get these readers to super function are all being rolled out in this round of software upgrade.
Yep. One more question, and I think we're done. How deeply embedded in the concrete can the sensor tag be? And obviously, there is the temperature does get warm in the concrete as it cures. And the other question is, what temperature can a tag withstand? Answering the second one maybe first is to say I think that's probably a question best for SmartTrack to answer about what temperature can the tag actually withstand.
Yeah, although it's kind of a funny story here because Bill says you got to bake the tags, and I come from the semiconductor industry where baking is an oven at 600 degrees C, and so I'm not exactly sure what to do, and I'm like, what the heck? I throw it in my oven at home and toast those babies, I think 250. And
Don't come out looking so good, do they?
No, they came out fine. But Bill responds to me before I this, and he says, I don't know. Here's the temperature we suggest, which was, I think, 85 degrees C. So the answer is they can go pretty hot. How far you can go into concrete's an interesting question. It depends on a few things. Obviously, when the concrete is wet, it's going to be, the penetration depth isn't as far. As it cures and the water content goes down, you can punch further and further into the concrete. And we're happy to work with you on the specifics, but I think Bill has commented to me that we can punch into several inches of concrete and detect the tag there.
So we have someone in the know who's given some advice. So the depth in concrete, 7 to 15 centimeters, and for soft tags about 100 degrees centigrade. Obviously with a hard tag they can go much, much higher.
And that must be a European somebody in the know.
Yeah, thanks Bill. And just another question was which tags were we showing? We were showing the dog bone, the sensor dog bone there. Okay, I think we're done. Thank you very much, everyone. We will follow up in the email, send you a link to the video once we finally get around to putting it into video. And we will definitely also in the email tell you who's won the prize of the reader.
And the coffee cup.
And the coffee cup.
Okay, thanks everybody for attending. Again, give us good problems to work on, and we will do our best to thrill you.
Yep. Okay, thanks very much, everyone. And,
Happy Halloween.
Happy Halloween, yeah.